Okay guys, in this video I will show you the maximum range and the time of flight for the launch at some height. On the left hand side you see the horizontal launch from the origin, and you know that the time of flight is twice the initial velocity over g times sine of the angle, the maximum height, and the range. On the right hand side I will prove these new equations for you. The x, where it lands, the maximum height, that is trivial, is the height plus h. It also trivial that it happens at r/2. But what is not so trivial is to find the time of flight is the bottom right equation. The bottom right equation and where it lands. We are going to take the limit. So if we make h0, the left hand side equation is supposed to be the right hand side equations. And we know that if the range is sine of twice the angle, the function is maximum at 45, sine of 2 times 45 is 90, sine of 90 is 1. And the maximum value is square of the velocity divided by g. For this case, we are going to see that equation for where the object lands yields an equation for the maximum range that obviously depend on the height, is twice the square root of epsilon squared per epsilon. And epsilon is, interestingly, is the ratio of the initial kinetic energy and the initial potential energy. However, this is a kinematics problem. We solve this using the kinematics equation. There is no mass here. The only forces acting is gravity, and on the left hand side you have mass times g. On the right hand side you have mass times acceleration. The mass cancel. But I put the mass over there just to see that is indeed the ratio of the kinetic energy over the potential energy. And the angle depends on the initial kinetic, on the initial velocity and the height by that equation over there. It's trivial to take the limit now. If you know, if h goes to 0, epsilon goes to 0, goes to infinity, and that equation over there, when epsilon goes to infinity, converges to 1, and arcotangent of 1 is 45. So this equation is consistent with everything with h is 0, and we are going to verify these results doing an experiment using the simulation, just to see that there is no mistake or anything.